Power system analysis. Today we are going to solve a problem in bus impedance matrix using bus building algorithm. Problem number 2. Determine Zbus for system whose reactance diagram is shown where all the impedances are given in per unit. Preserve all the nodes. So this is the circuit given in the question, which consists of 4 nodes and a reference node. Now we are going to solve this problem to find the Zbus matrix using bus building algorithm method. Solution. From the diagram it is clear the number of buses is 4. So our final Zbus matrix will be of 4 cross 4 matrix, which consists of this 16 parameters. Now we will see the steps to be followed to solve this problem. Step 1. From reference bus 0 to bus 1, we are considering this reactance J1.25. You will be getting 1 cross 1 matrix. And step 2, from bus 1 to bus 2, now the bus 1 become existing bus and bus 2 become new bus. We are considering this reactance J0.25. So the matrix become 2 cross 2 matrix. And step 3, from this existing bus 2 to new bus 3, considering this reactance, you will be getting a 3 cross 3 matrix. And step 4, from existing bus 3 to new bus 4, considering this value, you will be getting the 4 cross 4 matrix. And now step 5, from existing bus 4 to the reference bus 0, considering this value, you will be getting the 5 cross 5 matrix. So at this point you got 5 cross 5 matrix, but this problem consists of only 4 buses. So the final matrix is of order 4 cross 4 matrix. So in order to reduce the 5 cross 5 matrix to 4 cross 4 matrix, we are applying node elimination technique and the matrix become 4 cross 4 matrix. So up to 5 steps, we consider this reactance, this one and this one and this one. So this reactance is left over. So now in 6th step, we are going to consider this reactance. So from existing bus 2 to existing bus 4. So between that the reactance of J0.4 is connected. So again the matrix become 5 cross 5 matrix. Again we are going to apply the node elimination technique and bring the final answer in 4 cross 4 matrix. So these are the steps to be followed to solve this problem. Now we will see one by one. Step 1. From reference bus 0 to new bus 1, considering this reactance, Zbus is of Z11, 1 cross 1 matrix, the value will be J1.25. And step 2, from existing bus 1 to new bus 2, considering this reactance J0.25. So in this case, you will be getting 2 cross 2 matrix, you will be having 4 parameters. Z11 you can directly take from step 1, you can substitute Z11 directly. And simply you can copy this Z11 to Z12, it becomes J1.25. Similarly in the column wise J1.25, and this value Z22 will be calculated like this. Z22 is equal to the previous values, either Z12 or Z21, you have to take J1.25 plus the new reactance which we considered in the step 2, that is J0.25. So if you add this 2, you will be getting J1.5. So that will be substituted here in Z22. So this is the 2 cross 2 matrix Zbus at step 2. In step 3, from existing bus 2 to new bus 3, we are going to consider J0.125 reactance. So here you will be getting this 9 parameters. Out of this 9 parameters, this 4 parameters already we found in second step. Directly you can substitute those parameters here and simply copy paste the parameters in row wise and column wise. J1.25 here, J1.25 here, J1.5 here and J1.5 here. Simply copy paste. And the final value Z33 will be calculated like this. Z33 equal to the previous value, that is either Z23 or Z32. This J1.5 you need to take plus the reactance which we consider in step 3, that is J0.125, you have to add here. So adding this 2, you will be getting J1.625. So substitute here, you will be getting a 3 cross 3 matrix at this step 3. So this type of procedure, simply copy pasting procedure, this can be followed in the following cases only, that is from reference bus to new bus or from existing bus to new bus or from existing bus to reference bus. In these three cases only you can follow this type of procedures. Step 4, from existing bus 3 to new bus 4, considering J.2 reactance. So you will be getting 4 cross 4 matrix. So you will be having 16 parameters. Out of this 16 parameters, you know these 9 parameters from step 3. Directly you can substitute those 9 parameters and simply copy paste the row wise and column wise. J1.25, J1.5, J1.625, here J1.25, 1.5, 1.625. The final value Z44 will be equal to the previous value either from Z34 or Z43. You can take J1.625 plus the new reactance which we consider in this step J.2. If you add, you will be getting J1.825. Substitute here, you will be getting the 4 cross 4 matrix at the end of step 4. Now step 5, from existing bus 4 to reference bus 0, considering this reactance J1.25. So you will be having 5 cross 5 matrix which consists of 25 parameters. Out of this 25 parameters, you will know this 16 parameters from the step 4. Directly you can substitute those 16 parameters and simply you can copy paste these parameters, 1.5 here, 1.625, like what we did in the previous steps. And this final value Z55 can be calculated like this. The previous value either from Z45 or Z54, you can take J1.825 plus the new reactance which we considered in this step. Adding, you will be getting J3.075. So this is a 5 cross 5 matrix at the end of step 5. So now before proceed this problem further, you need to see here the matrix is of order 5 cross 5. But in the beginning of the problem, I mentioned that the given problem is of 4 bus system. So the final Zbus matrix is of 4 cross 4 matrix. But here in step 5 itself, we got 5 cross 5 matrix. So what we need to do, you need to reduce the 5 cross 5 matrix to 4 cross 4 matrix by applying the node elimination technique. The elements ZJK of the new impedance matrix is given by this formula, where n is equal to 4 and j equal to 1, 2, 3, 4, k equal to 1, 2, 3, 4. So by substituting the values in this formula, you will be getting the 4 cross 4 matrix. This is what you will be getting after the reduction of 5 cross 5 to 4 cross 4. You will be getting the 16 parameters. Consider the 5 cross 5 Zbus matrix. Applying this in this formula, first parameter Z11, Z11, so j equal to 1, k equal to 1, so it becomes Z11 minus Z15, so j equal to 1, n plus 1, n is 4 plus 1 is 5, so 1 5, and Zn plus 1, Z5 1 divided by Zn plus 1, n plus 1, so n plus 1 is 5, n plus 1 is 5. So substituting all the values from the matrix we obtained, so you will be getting J.7418 as answer. Similarly, for the next parameter Z12, that is equal to Z12 minus Z15, Z52 divided by Z55. Substituting the values, you will be getting J.6402, and this value will be equal to Z21. Similarly, for Z13, you will be getting J.5894, that is equal to Z31. Z14, J.508 equal to Z41. Similarly, Z22, Z23, and that is equal to Z32, Z24, that is equal to Z42, Z33, Z34, that is equal to Z43, and finally Z44 equal to J.7418. So all the 16 parameters we have found, and we are going to arrange this in matrix form. So you will be getting the 4 cross 4 matrix like this. So this is the 4 cross 4 matrix at the end of step 5. And now in this diagram, step 1 we consider this reactance, in step 2 we consider this reactance, step 3 we consider this reactance, step 4 we consider this reactance, and step 5 we consider this reactance. One more reactance is left, that is J.4, which is connected between bus 2 and bus 4. So now in step 6 we are going to consider this reactance from existing bus 2 to existing bus 4. So here we need to note one thing, both the buses are existing bus. Second bus is also existing bus, fourth bus also existing bus. So we cannot apply the copy paste procedure here. So for this, you will be having a new procedure. So in this case, for new bus impedance matrix, so already we got 4 cross 4 matrix here. So we are considering one more reactance. So what happens, this Zbus matrix become 5 cross 5 matrix. So fifth row and fifth column will be added. So the elements of fifth column are obtained by subtracting the elements of fourth column from the second column. So why I am putting fourth column and second column? Because the reactance is connected between second bus and fourth bus. That's why I am mentioning fourth column and second column here. Similarly, the elements of fifth row are obtained by subtracting the elements of fourth row from the second row. So 2 minus 4, or simply you can say row 2 minus row 4, that gives you row 5. Column 2 minus column 4, that gives you column 5. So we are going to apply this in this matrix. So you will be getting like this. So in the row wise, row 2 is 0.6402 minus 0.508, that gives you row 5. Similarly, in the column wise, 2 is 0.6402 and 4 is 0.508. Subtracting, you will be getting a column 5 in all these parameters. And the final value, this value is obtained by using the formula. So the element Z55 is given by Z55 equal to ZB plus Z22 plus Z44 minus 2 into Z24. So this formula is easily arrived by considering the buses in between which the reactance is connected. So here that reactance J.4 is connected between bus 2 and 4. So you are considering Z22 and Z44 here, minus 2 into Z24. And this ZB is the reactance what we are considering now, that is J.4. So this formula is derived based on the buses in between the reactance is connected. So substituting the value, ZB is J.4, Z22 from the matrix, Z44 from the matrix, and Z24 is also from the matrix. So you will be getting J.6906 as answer. Substitute here, you will be getting the 5 cross 5 matrix like this. So again you need to think, we considered all the reactances, but the final answer we got is 5 cross 5 matrix. So this is not the correct answer. Since we are having only 4 buses, the final answer must be of 4 cross 4 matrix. So we need to reduce this 5 cross 5 matrix to 4 cross 4 matrix by applying the node elimination technique. So the fifth row and fifth column can be eliminated using this technique. So the same formula which we done in the fifth step, considering this 5 cross 5 matrix. So applying the values of 5 cross 5 matrix and this formula, you will be getting the 16 parameters of the 4 cross 4 matrix. So Z11, Z12, Z21, Z1331, Z1441, Z22, Z2332, 2442, 33, 3443, and finally Z44. So arranging all these values in the matrix form, you will be getting the final answer in 4 cross 4 matrix. So this is the final Zbus matrix for this problem. This is how you need to solve this problem using bus building algorithm method.